Hi guys, so welcome back to our lecture series. So again, this is Teacher Aya. So now we'll be discussing about exponential inequalities. So how do we solve an exponential inequality? So there are two properties that we need to consider in solving an exponential inequality. So first is if the base is greater than 1, then the inequality symbol must retain. So always remember that if the base on our given exponential inequality is greater than 1, then the given exponential symbol or inequality symbol rather must retain. So second property is if the base second property is if the base is less than 1 but greater than 0, then the inequality symbol must reverse. So always remember these two properties. If the base is greater than 1, then it means the given inequality symbol must retain. But if the base is less than 1 but greater than 0, the inequality symbol must reverse to its opposite. Alright, let's have an example. Four to the power of x plus 2. So how about if you're given this inequality, exponential inequality 4 to the power of x plus 2, which is greater than 8 to the power of 2x. So first step in solving the exponential inequality is you must rewrite both the exponential into the same base. So what do you think is our common base given that the base here is 4 and 8? Yes, you can rewrite the 4 by 2 squared. You multiply it with the exponent of the 4, which is x plus 2 greater than, and 8 can be rewrite or its equivalent exponential form is 2 to the power of cube times 2x. First step is you need to rewrite it with the same base. Next step is you need to determine the base. The base here is equal to 2. Now 2, is it greater than or less than 1? It's greater than 1. By using our two properties, what will happen to the inequality symbol? Retain or reverse? Yes, you're right. Since the base is greater than 1, then it means that our inequality symbol, the given inequality symbol, must retain. So you just copy. And with this, after you determine whether to retain or to reverse, and since both the base are already equal, you can automatically omit that and copy our exponent. Then you distribute 2 times 2x, that is 2x, 2 times 2, that is 4, greater than 3 times 2x, that is 6x. You're combining like terms, you transfer all with the terms with the same variable to the other side and all the constant to the other side. So you have 2x, positive 6x will become negative 6x, and the positive 4 will become negative 4. 2x minus 6x, that is negative 4x, greater than negative 4. Our goal here is to solve for the value of x, so you divide both sides by negative 4 So that will have x to the other side. Negative 4 divided by negative 4. You are dividing like signs. It means the resulting value should be positive. Yes. And now, since you divide it by a negative number, what will happen to our inequality symbol? Yes, every time you divide it or multiply it with a negative value, then your inequality symbol must change into its opposite. So the greater than will become x less than 1. Now, we can do the checking in order for us to verify whether we have the correct solution. So, since the x should be less than 1, then we can let x be equal to 0. With the x value equal to 0, we can substitute it to our original inequality. Then we'll have exponential inequality. So instead of writing x, we change it by 0 plus 2 greater than 8 to the power of. The checking helps us to verify whether we have the correct solution if our given value satisfies to our given exponential inequality. So 0 plus 2, that is 2. Any number multiplied to 0 is always 0. 4 squared, that is 16, is greater than 8 to the power of 0. Any number raised to 0 is always equal to 1. The 16 greater than 1? Yes. So with this checking, we can verify that our solution is really x less than 1. Therefore, the solution set is x should be less than 1, so from negative infinity to positive 1, where 1 is not included. Do you have any questions in solving exponential inequality? Alright, let's have another example. How about if you're given 2 to the power of 5 raised to 5x minus 1, which is greater than or equal to 4 over 25. We're just looking at our bases. We can determine that it is greater than or less than 1. But let's still continue our process. So what do you think will be our common base? Yes, it is 2 over 5. So you just copy 2 over 5 to the power of 5x minus 1. Then you rewrite 4 over 25 with a base 2 over 5. What do you think will be our exponent in order for us to get 4 over 25 with base 2 over 5? Yes, we write it's 2. 2 squared is 4. 5 squared is 25. Right. Since you already have the same base here now, we already transformed it with the same base. Next step is to determine whether our base 2 over 5 is greater than or less than 1. Is it greater than or less than 1? Yes, it's less than 1. If our base is less than 1 and greater than 0, then it means that our inequality symbol must reverse. Or we will change it into its opposite. Right? So let's continue. We already have the same base. If you have the same base here, automatically you can omit that and copy our exponent. And remember, using the property, our inequality symbol must reverse. So the greater than or equal to will become, yes, less than or equal to. The same process, you combine all like terms, remain the 5x here, less than 2, the negative 1, you will transfer it, will become positive 1. So 5x less than or equal to 2 plus 1 is 3. Dividing both sides by 5, then you'll have x less than or equal to 3 over 5. Do you have any questions? Alright, so let's do the checking. X is less than or equal to 3 over 5. We can let our x here be equal. Remember that it's stated here that x is less than or equal to 3 over 5. So we can let, since x is less than or equal to 3 over 5, we can let x be equal to 0. Right? So you substitute it to our original inequality, exponential inequality. So 2 over 5, 5 times 0 minus 1, greater than or equal to 4 over 25. Now, 5 times 0 is 0, minus 1 is negative 1. Greater than or equal to 4 over 25. And remember, if you have a negative exponent, you will just get its reciprocal to make it a positive exponent. So what is the reciprocal of 2 over 5? Yes, it's 5 over 2, and the exponent will become positive. Or that will become positive 1 greater than or equal to 4 over 25. Or, since this is 1, you can just omit that and leave as 5 over 2 over 4 over 25. Now, does 5 over 2 greater than or equal to 4 over 25? Remember, on our first fraction, the numerator is greater than compared to our denominator. It means that the possible value of this is greater than 1. And on the other fraction, or on the other side, our numerator is less than compared to our denominator. Then it means that the value of this fraction is always less than 1. Do you have any questions? So it means x less than or equal to 3 over 5 is satisfied to our given exponential inequality. Therefore, the solution set is negative infinity to 3 over 5. As you have noticed that our inequality symbol involves equal to. It means 3 over 5 is included. You can use 3 over 5 as the value of x. Now, do you have any questions in solving exponential inequalities? So just always remember, class, that in solving exponential inequalities, you must consider these two properties. First, if the base is greater than 1, then it means that given inequality symbol must retain. But if the base is less than 1 but greater than 0, then it means the inequality symbol must reverse. You must change it into its opposite. And then you can just follow the one-to-one property. Just make sure that both the exponential inequality are on the same base. Then you can just omit the base, then copy our exponent. That's all for today. Thank you for listening. Again, this is Ma'am Aya.